Hello everybody and welcome back to this UP tutorial series on Python, and today we'll be covering numeric data and how to manipulate it in Python. In programming languages, variables are given a type to help the computer classify which operations are applicable to it. In strongly typed languages, this type must be set by the programmer when the variable is created. Python, though, is a weakly typed language, meaning the interpreter will be able to roughly figure out the type on its own. When dealing with numbers while programming, there are two main types: integers and floats. Integers are whole numbers and floats are decimal numbers. There are many cases in Python where only one of these types will be accepted, so it's important that we learn how to keep and convert between them. With this variable here, puppies, the computer will interpret this as an integer, whereas this variable, bank account, will be interpreted as a float. Now we can see here, if I uncomment this and run, using the built-in function type in Python, we can see that puppies is seen as an int and bank account is seen as a float. Now, if we want to convert between the two types, if we would like to make puppies a float, or if we would like to make bank account an integer, we can use in the built-in float or int functions to convert the type. As you can see there, we've now made puppies a float, and we've now made bank account an int, and some information is destroyed here. There's another instance where type will be important, which is if we accept our numbers as input where they're seen as strings in Python, such as here. If we try to use an operator on this, then we will see that the strings are added together and they're not treated like integers. And in order to fix this, we need to specifically tell Python that we want to use these as integers. Like that. Now, like a calculator, Python has arithmetic operators we can use to manipulate numbers. We have addition, subtraction, multiplication, and division. We also have integer division, where the return value will always be the quotient floored to the nearest integer. To calculate an exponent, we use two asterisks, where the base precedes the power. So in these cases, hold on one second. There we go. Five plus 3 is 8. 5 minus 3 is 2. 5 times 3 is 15. 5 divided by 3 is 1 2/3. The integer division of 5 and 3 is 2/3, 1 2/3 rounded down to 1. 5 to the power of 3 is 125, and 5 modulo 3 would be 2. Modulus will return the remainder of the division of two numbers. An example where this is useful is when determining if a number is even or odd. If it's even, when divided by 2, it will have a remainder of 0, so x mod 2 will be 0. If not, x mod 2 will be 1. You can see this here. This is useful for determining whether or not a integer is even or not. And I'll use this isEven function I've created here to see that 3 is not even, where a number like 10 is even. We also have comparative operators to compare between two numbers, such as equals, not equals, greater than, less than, greater than or equal to, or less than or equal to. I just need to comment this out. Now we can see if we run this here, we will have our return values in booleans, which is true or false, to show that 5 does not equal 3. It is true that 5 does not equal 3. 5 is greater than 3. 5 is not less than 3. 5 is greater than or equal to 3, but 5 is not less than or equal to 3. Now, we also have a shorthand for recursive operations. So, for example, if we wanted to increment a number, such as this variable here, num, which is equal to 22, we could increment it by saying num is equal to num plus 1. And this does work. However, because we want to do this so often, Python has included a shorthand for this, where instead of typing num equals num plus 1, we can just say num plus equals 1. Now this works for any arithmetic operation, so we can do 5 times equals 2, which will multiply 5 by 2, or whatever num is by 2, and so on. We also have a few other helpful functions, such as the absolute value, which is ABS, and we also have the ability to round in Python, which is built in. We can do this using ABS and round. So the absolute value of negative 24 is 24, and we would round 27.8321 to 28. If we include another parameter in rounding, we can specify to which decimal place past the decimal point we would like to round to. So if I include a 1 here and run, we can see we round to the 10th place. All right. Thank you, and thanks for watching.